Hi folks, Mr. Long here with a screencast on equations of lines, which I know seems kind of weird that a line would have an equation, but it's all about this idea of initial value and rate. So what we're going to do is we're going to explore this idea of what's called a linear or a line relationship, so a constant rate of change. And we're going to explore this by looking at scales. So we're going to assume that we've got, so we take a look here, you've got a scale with 4 blocks on it. So we're going to say they're candies, or maybe I'll call them blocks, I'm not sure. But anyway, you can see I've got 4 candies on this scale. Now, on the right side, how is it different? There's still 4 candies on the scale, but what are the blocks inside of? Okay, the blocks or the candies are inside a container, a cylindrical container. So here, what does the overall weight on the scale depend on? Does it depend on just the blocks or the blocks and a container? Okay, so we can think about that. And then over here, what does the weight depend on? Does it depend on the blocks and the container, or just the blocks or just the container? And another question is, if as I add more blocks onto the scale, so I'm putting more and more blocks in, does the weight of the container change? Or is that constant? Right? Or if it's empty, if there's no blocks on here, what's the initial weight on this scale? Is it 0 or is it the weight of the container? Similarly, over here, if there's no blocks at all on this, and I'm not using a container, what's the initial weight? If I took those 4 blocks off, what would the weight be? And that's the idea of initial value. Okay, so that's what we're going to explore today. So what we're going to do is we're going to start by going through this table, and it's one of those things where I'll do the first half and then you're going to do the second half, and it's in one of those Google Sheets that there's boxes, so you can see there's text boxes to fill in different places. So let's get going. So what we're going to do first is make a table up, and this is one of those horizontal tables, so the number of blocks or candies is going side to side this way, and then the weight is going side to side this way. Okay, so it's a normal table turned on its side. So first of all, let's think about this. So this is n represents the number of blocks. So if there were 0 blocks on this scale, so this scale right here, if I took all the blocks off, what would the scale weigh? Well, there's no container there, so it would have to be 0, right? Zero blocks will result in a weight of 0. Now, if there's 4 blocks on the scale like there is here, they weigh a total of 20. Right? There's no container on the scale, so it has to weigh 0 at the start. This delta n represents, delta, remember, means change. So how much did the number of blocks grow by, or candies grow by, from 0 to 4? So it would be 4 minus 0 equals 4. Okay, 4 blocks or candies, whatever you want. Now, whoops, what about change in weight? So when there were no blocks on, it weighed 0 grams, and then when I put 4 blocks on, it weighed 20 grams. So that's going to be 20 grams minus 0 grams. So the total change in weight is 20 grams. Now, what we want to do is, what would the ordered pairs be? Remember, ordered pairs are x comma y, right? Remember that? So x comes first, then y comes second. So this 0 goes with this 0. And then this one here, 4 blocks has a weight of 20 grams. So that's 4 and, and 20. Okay, 4 and 20. So 4 blocks weighs 20 grams, 0 blocks weighs 0 grams because there's no container there. Now, how do we get rate? Rate is rise over run, or delta y over delta x. So it's going to be in grams per block. Okay, so I'm going to take the change here in weight, which is 20, and the change here in blocks, which is 4. So on the top, it's changed by 20 grams, and that's an increase of 4 blocks, BL. So 24 goes into 25 times. So that's 20 divided by 4 is 5 grams per block. Okay, that's the rate. So in other words, every single time I add a block, it weighs 4 grams, which makes sense, right? Or, sorry, that shouldn't be 4. 20 divided by 4 is 5. Okay, so 1, 2, 3, 4 blocks, and they weigh 20 grams, so it's 5 grams per block. All right, initial value. What is the initial value? So in other words, if there's no blocks, so if I take all the blocks off, what's the weight that's going to show on the scale? Well, it's going to be 0, right? It's going to be 0. So what I can do is I can take this. Oh, no, I can't. Oops, edit, undo. So you know what I'm going to do is I'm just going to take this. Well, that line there, I can't even do that, but can I? Uh-oh. Nope, I don't want to do that either. So what I'm going to do is ungroup that right now. There, that's actually okay. I can ungroup that. And then I'm going to bring this down because the initial value for this is how much does it weigh with no blocks? Well, it's going to weigh 0, right? And your line is going to go like this. It's going to start at 0 and then increase. Okay? So would the initial value be 0? Yeah, for sure it would, because look, 0 blocks weighs 0 grams. This is your initial value right here. Okay, that's your initial value right there. So that's what it'll look like. So what does the weight of blocks on this scale look like? So it'll be every time we add a block right here, it goes up by 5, right? That's the rate. So the weight starts at 0 and it goes up by 5 grams per block, right? That's the part that repeats. 5 grams for the first block, 5 grams for the second block, 5 grams for the third block, and that is the initial value right there. Okay, so then it means it starts right here. That weight of 0 means there's no container. Okay, so that's how you go through that process on this scale. Now this one over here, you're going to have to do on your own. Now the only thing that I'm going to give you for here to get you going is this one here. And that's going to be the weight if there's absolutely no blocks on the scale still weighs 8 grams. Or it still reads 8 grams. You've got to think about where that 8 grams comes from. Right? Where does that 8 grams come from? So remember, I'd be removing 1, 2, 3, 4 blocks off. Okay? And remember that that is also your initial value. That's the weight before you have, or well, you can see right there, I have 0 blocks on the scale. Okay? So write 2 ordered pairs in the table, same sort of thing. So the first one would be 0 and 8. Maybe I'll add that one for you. That one's okay. And let's see, our rate calculation is going to be fine. Okay, so now what you're going to do, folks, is you're going to go through and you are going to finish the calculations here. Okay. By the way, we're going to call this is called direct variation. This is called partial variation, because you can see the scale reading depends directly on the mass of these blocks or these candies. Over here, it depends partly on the blocks, but partly on the container. And what I want you to remember is, does the container mass or weight change? Okay, is it a constant or is it a variable? So as I add more blocks, into this container, does the weight of the container change? And I want you to think about, if I have 0 blocks, the scale reads 8 grams. So how much is the weight of the container? And you're going to go through, and then you're going to come up with an equation as well, okay, for this one here. And for this one, you're going to move wherever this right here is the initial value, right? So is the initial going to be at 0, or is it going to be up here at a different number? Okay, so you have to think about, you can just leave that there, or is it going to be starting at 0 down here, right? You're going to have to figure that out. Okay, folks, so good luck. What I want you to do is, I'm going to make this right here, I'm going to take all these out, and you're actually going to fill both sides in as you go through this. By filling in this side, it'll help you remember the process. Okay, so I am going to remove a bunch of this stuff, and then you'll work through both sides and figure out the equations for both. Okay, good luck.